Today we're going to look at how to solve complex conversion units. So we got all these three examples and I'll jump straight into it. All right, so we're going to first start with converting a nanometer to a millimeter. So my first step is always just to establish a general conversion factor. Okay, I'll give you the question at hand. So I'll just write out the general problem, and now we want to figure out the conversion factor between nanometer to millimeter. And on your formula sheet, which probably has the SI prefixes, it will say your nanometer. This is a trick question, guys. Your nanometer is 10 to the negative 9 and your millimeter is 10 to the negative 3. Don't listen to this. This is in reference to your regular meter, but even though millimeter is 10 to the negative 3 to a meter, but the relationship between millimeter and nanometer is actually the difference between this negative 9 and negative 3, which is going to be 9 minus 3. 10 to the power of 6 will be the difference between nanometer and millimeter. So since millimeter is larger, we know that 10 to the power of 6 will be on nanometer to equate to 1 millimeter. You can also say, it's also fine to say 10 to the negative 6 millimeters equates to 1 nanometer. That is also fine. So I'm going to insert our conversion factor, which we've established, into our problem with the unit that I want to cancel at the denominator. So this cancels, which is fine. We don't have any squares to worry about, so we can just solve this right away. The answer is going to be 8.89 times 10 to the negative 6. So that will be our first answer. Pretty easy, right? So just first step, find the general conversion factor, but really be careful of this part. Your formula sheet with the SI prefixes will likely mess you up. So you want to be careful how you calculate their conversion factor. All right, we're going to jump to our second problem, which is dealing with squares. The number that I'm going to give is 3.89 times 10 to the power of 5. 3.89 times 10 to the power of 5. All right. So as our first step, we are going to just write out the general problem, set out the scene times. It's always going to be what we have at hand times the conversion factor. Now, I like to write our conversion factor at the bottom so we don't accidentally confuse ourselves with too many tasks at hand. Okay, our general conversion factor. As you see, it's general conversion factor. Don't worry about the squares just yet. On your SI prefix formula sheet, it's going to be centimeters. It won't say anything, but it's actually going to be 10 to the negative 2 in respect to just a regular meter. And your micrometer will be 10 to the negative 6 in respect to a regular meter. But the difference between centimeters and micrometers will be 6 minus 2. Their difference will be 10 to the power of 4. And since centimeters is a bigger person here, 1 centimeter is going to equal to 10 to the power of 4 micrometers. Or you can say 1 micrometer is equal to 10 to the negative 4 centimeter. So this is, once again, a very important step to remember. All right, so we're just gonna put our things here with the unit we want to cancel at the denominator. But we cannot cancel it just yet because we have a cube, we have a square here, and we have nothing here. So if you try to cancel, you would be left with centimeters times micrometers instead of just micrometers. All right, so that brings us to the second step. If you're dealing with squares or cubes, your next step will be you're gonna square your conversion factor. So we're going to square our conversion factor. Now there is two things that are easy to forget, easy to mess up. When you square it, the first thing you want to distribute everything everything. So don't forget about the numbers, don't forget about the units, don't just distribute it to the units and forget the number. And the second step that people tend to forget easily is your exponent laws. For two exponent, they're multiplying them, so it's going to be 8, and we're going to add the square to this unit, or we might as well just add square to 1 because so that we've remembered to add it to every number, even though 1 squared 1 is just going to be 1. So this is our squared version of our conversion factor. What you're going to do is you're going to multiply this number with your new conversion factor, and your answer will end up being 3.89 times 10 to the power of 5, micrometers squared. All right. Now we're going to go to our last problem of the day. The number that I will give you will be 2.43 times 10 to the power of 10. And it's going to be kg to grams, and then meters squared to centimeters squared. Feel free to pause this video and jump back when you think you have an answer. All right, I'm going to get started on how to dissect this problem. We have a lot to deal with, but first of all, in this problem, we can dissect it into, we see that we have 2.43 times 10 to the power of 2 kg, and we can turn that into grams first. We can worry about meters squared later because it's just 1 meter squared to 1 centimeter squared. So that has nothing to do with our complicated number here. So we'll just convert kg to grams first, which is going to be multiplied by 100. Multiply this number by 1,000 to get grams, which is going to bring us to this. All right, so that's this. S with the exponent minus 2 just means it's actually at the bottom of the denominator here. So this will be our grams version, but now we need centimeters squared. How we're going to do this is we're going to multiply by our conversion factor again. Remember, first step is looking for your general conversion factor. We know that 1 meter equals 100 centimeter, and if you want 1 meter squared, you got to square everything. So now we can have our conversion factor, check, and we have squared our conversion factor, check. So now we can just multiply while canceling out the units we don't need. And finally, your answer will be 2.43 times 10 to the power of 9. Let's write that prettier. Grams, centimeters squared over S squared. So as you can see here, we just, in one step, combined writing a general conversion factor, and then we also squared everything, remembering to distribute everything evenly to the numbers as well, and we got our answer. If this video was helpful, remember to hit a like and share with those that you think will find this useful.